Okay, so let's take a look here. All right, there is a way to do a translation using patty paper, but we're not going to worry about that, okay? It's a little bit tricky. It involves using 2 lines of reflection, okay? Instead, we're going to go right into the actual, translation using the coordinate plane and stuff like that. Okay, so, anyway, looking on page 64 here, we can see that one way we're going to be translating, okay, figures is using something called a vector. Now, has anyone talked about vectors maybe in their physics class or science class before? Okay, so a vector, what does that kind of look like in our geometry terms?
Array.
It looks like an array, doesn't it? Okay. The difference about a vector, though, is that it does not go on forever. You can see that it has a starting point just like an array does, and then it goes to an ending point. Okay. This arrow does not mean that it goes on forever. In this case, the arrow means that you're kind of moving, so to speak, from E to F. And in fact, if you look at the way it's named, look how similar it looks to an array. Okay? The only difference between a vector and array with the labeling is that it doesn't have the other piece of the arrow there. It only has the one piece of the arrow. You see that? It doesn't have the little bottom part of the arrow there. So that's the difference between an array and a vector. They are different things. Arrays go on forever in the direction they're pointing. Vectors have an initial point, just like the array does, but it only goes to this arrow and stops. Okay, so it goes this direction and stops. Okay.
Draw it to the point.
Why don't they just put the arrow at the point or something like that?
No, just connect it
like a segment almost. So I think because the idea of a vector has a direction though too. If you don't put an arrow there, you could, am I supposed to go from here to here, or am I supposed to go from here to here? So I think that's what the arrow does. It kind of shows a direction. That's your starting point to this ending point or terminal point. The terminal point is kind of part of it, yes. Okay, you can kind of think of this as it's almost like a translation, right? I mean, what is this? It's almost translating point E, translating this direction, and then stopping at point F. So it's almost like a translation in itself there as a picture. Okay? So, and again, you can name the vector either this way using 2 letters, EF, or just the single letter name, vector V. It's like a cursive kind of V, though. Remember, you might want to get your paper open, 64, okay? All right, I know that starbursts are important too, but this is also important, okay? I know, it's a pink starburst. That's like winning the lottery. All right, translations. So we're going to use vectors sometimes to describe translations. All right. A translation is a transformation along a vector such that the segment joining a point and its image has the same length as the vector and is parallel to the vector. Okay, so what do I mean by that? So you have your little vector over here that's pointing us into which direction to go. And then you'll see we take B and copy that exact same vector in the exact same direction and the exact same length, and it goes to B prime. So if you can imagine taking this vector and just putting it on, starting at point B, and then it moves it in the exact same direction and length to B prime. C to C prime, A to A prime, also all use the exact same vector. Okay? So, here we go. Let's take a look at how we're going to use that. So if we go up here to example A, okay, we're going to take a look at this shape, triangle ABC, and we want to translate it. That means we want to slide it, right, using this vector. So how is this vector kind of directing us or showing us how to move? Well, my starting point is right here, and my ending point's right there. So which direction is our vector telling us to go? So right how much? 1, 2, 3, I see 4, right? It goes over 1, 2, 3, 4 units, and then we have to go up 2. So this is almost like a slope, you can think of it as. We're going to go right 4 and up 2. So then to do it for this shape, which points do I need to translate? All 3. So each of these 3 points, I'm going to start with point A. I'm going to go right. 1, 2, 3, 4, and up. 1, 2. And there's A prime. Okay? There's A prime. Again, right 4 and up 2. And then do same thing for B. Right, 1, 2, 3, 4, up 1, 2. And there's B prime. Okay, and then same thing for C. Right, 1, 2, 3, 4, and up 1, 2. There's C prime. Let's go back to A. You mean up or down versus right and left? So let's check. Let's just check. So Jaden's question was, do we have to go right, left first, and then up, down, or can we do it the other direction? So let's just see. So again, if I do it the other direction, Jaden, it would be up to, then right for.
No, I mean like, could you ever do upward versus?
Yeah, so let me show you. Up, 1, 2, right, 1, 2, 3, 4. It would end up being the same spot. So yes. As long as you make sure you do both things, though, Jaden, that's what's the important part.
The vector line will always be there, right?
I'm sorry?
The vector line, it'll
The vector line for when we're using a vector, yes. So again, we just connect the dots, and then that's our shape. We've translated it.
It's actually pretty easy.
That's not too bad, right? Okay, now let me ask you a question. If I were to draw a segment between A and A prime, so if I were to draw the segment A to A prime, how do you think that would compare? Is it equal to, like, C, C prime?
Yeah.
Is it equal to B, B prime? And the answer is yes, these things are equal. So from A to A prime, that length is the same as from C to C prime, is the same as from B to B prime. How do we know? Well, because we did the same exact motion for each thing, right? We went right for up to. So right for up to, the length from here to here is going to be the same because we went right for up to there and right for up to there. Okay? So there you go. That's how you do it. This seems easy, but it can get kind of tricky. Just be careful. Make sure you're always just doing every vertex. Just go right for up to, put your new point, and name it. Naming it really helps too. Okay, we transformed A, right for up to, that became A prime. All right, so that's what you want to do there. Okay? So there it is. And you can kind of see an example of it right here, what they kind of showed a worked out example here. You can see that this vector from C to where our C prime ends up, that's the same as that one, same as that one. They're all the same vectors, same direction, same length. And it ends up giving us that answer right there. Okay, it translates. All right, let's try this one for letter B. Okay, so now for letter B, all right, Cordell, how's this vector telling us to move here? What directions? And you can use your own paper, I was going to say, if you can't see mine. Are we going to move left or right according to the vector, Cordell? Left how much?
3 left.
Yep, 3 left, you got it. And then how much up? Are we going to go up or down then? Up how much?
5.
1, 2, 3, 4. You got it. Yep, up 5. That's pretty long there. Okay. So again, every one of these points, we're going to move left 3 and up 5.
Isn't that a negative 3?
So you can call it a negative 3 if you want to, but since we're moving left 3, I'm just going to leave it as a 3. So again, just count. So let's start with point A, and just count left. 1, 2, 3, and up 1, 2, 3, 4, 5, and put a point, and we'll call that
Point A prime.
A prime. Good. Okay, it's transformed. And then left 1, 2, 3, and up 1, 2, 3, 4, 5, and that's going to be B prime. Okay. And so. Okay. Okay.
Do you have to say that A prime is equal to C prime?
No, I just wanted to state that so you guys would have that, kind of just be able to think about that kind of thing, okay? The distance between the original point and its image is the same for every pair. So A to A prime is the same as B to B prime, is the same as C to C prime, is the same as D to D prime, okay? Now, if you do your translation, so here's a question for you guys. If you do your translation, and you look at your image, and you compare it back to your original or pre-image, if your image looks different than your pre-image, what does that mean? You did it wrong, okay? And you want to go back and fix it, okay? Because our image should look identical to our pre-image or original, okay? So if this looks different than this, you made a mistake. So make sure you fix it, okay? All right, any questions on that? All right. Let's move on then. So here's one for you all to try. So go ahead and try number 4 on your own. Okay, try number 4 on your own. Use that vector to translate.
Where's number?
You should have enough space, yeah.
Where is number 4?
How do we?
Number 4 is next page, 66. Number 4 at the top, please.
So would you be counting above the vector line or down?
Look at where the vector starts and to where it ends.
So I would. Am I gonna go down first or am I gonna go sideways?
You can go sideways or down first, it doesn't matter.
Yeah, that's
Either
what
one's
I'm
okay.
trying to figure out later. I don't know which side you're going to. Like the vector, I know it's going that way, so it's going
Whatever the point
to my
is.
left.
That's your starting point,
Yeah.
and it has to go down to this point right here. So you can choose to go left, right first, and then up, down, or you can go up, down first, then left, right, doesn't matter, as I was explaining to Jaden, she asked that too. So it doesn't matter which one you do first. If you want to use it like slope, you can always do rise over run. You do the rise first, and then the run, if you want. Okay. Bless you. Did you do it yet?
Good here, guys, we're good.
Don't forget to label your points too. I know it's a bit of a habit, but it's a good habit to get into. Okay? If you don't label your points, guys, do try and get into that habit. Good job, good kid. Well done. Yes. And you don't have to draw the connecting lines if you don't want to, but if that helps you there, that's fine. Don't forget the labels right there. So sorry. Good. You got to start here. So from here we can go down. 2, right? And then left, and right. So from point C, let's start here. Oh, you did it from A already, didn't you? Yeah. Okay, so let A prime. So I think you need to count. Down 1, 2, and then right 1, 2, 3, 4, 5. That's it. 1 over. And then try C. Okay. You don't have to. Okay. Looking good here, guys.
I told her she messed it up, but
So we should have gotten something like that. Yeah?
Yeah.
Okay. Sorry, did you get that point C okay? Good. All right, so now I'm going to show you something that's a little bit advanced. Okay, if you don't want to do that, so if you feel like you've got this down and you don't want to have to learn, some other way or just see another little trick we could use, then that's fine. But let me just show you something. For example, here for this triangle ABC, when I translate A to A prime, I had to go down 2 and left 5, and there would give me A prime. Now, remember that the sides of this triangle, for example, AB, what's the length of AB? 3, okay? What must A prime B prime be in length then? Must be 3, right? Because it's got to stay the same length. So here's the thing. I could, Jason, Derek, I could translate point B like I want to, or I could just use the fact that from A to B has to be 3 units. So I could just, once I have point A prime, I could just count, right, 1, 2, 3, and there's where B prime has to be.
How's 3?
Sorry?
How's 3?
Because from A to B is 3 units. 1, 2, 3. Start at A right there, over 1, 2, 3 to B. Okay? Sorry, if you can't see it, look at your paper too there. You can count it that way. Okay? So that's the same we can do with A prime to B prime. Now here's the other thing. C is 1, 2, 3, 4 units down from A. So again, instead of translating C if I wanted to, instead of translating C, I could count down 1, 2, 3, 4, and there's where C prime has to be. Okay? Now, the danger in this is that, if you miscount or something like that, so if you want to just always do the translation, that's fine, but you can check yourself that way too. It should be 3 there, 4 there. Okay, so that's another option that you have to maybe move those points. Okay? Alright. Moving on though. So that's one way to do translations, is using a vector. The other big way we're going to do translations is using the coordinate plane. Okay? So another way we can name a vector can also be named using component form, this, AB. Okay, if you kind of, I'll zoom in on that some. You can see there again, it's not parentheses. These are like kind of pointy parentheses. We've never really seen this grouping symbol before. Okay, but you name it kind of like you name the slope. So for example here, if I kind of get that picture on there, there we go. Okay, so if we look here, there's a vector PQ, right? We go right 5 and up 3, and so look how that shows up there. The x kind of like coordinate is a positive 5, the y coordinate is a positive 3. So that kind of shows you we're going to go right 5 and up 3. Okay, what would the vector form of this, the component form be of this vector? Okay, we're going left 5, so what would our first number have to be? Negative 5. And then we're going down 2, so what would our y component have to be? Negative 2. And so there's the component form of that vector right there. Okay, just
Yeah,
like
I'd rather
that.
just do it the other way.
I understand, but we need to be able to read this though. So maybe like if you have your choice, you'll pick this way, but you need to be able to write it this way and understand what it means. That's what's important here. Okay? So if you look,
Are we gonna have to do it that way on the test or something like that?
I might ask you to put it in like the component form, yeah, or you might be given something in component form and asked to do it. Okay, we're going to skip all this talk right here and just run right down here. Okay, so for example, if we want to translate something a number of units to the right, then we'll take xy and we'll add the a there. And this is not, I don't know why it's written this way. It should be written this way. These should be like
A
regular parentheses here, guys, not component things. These should be parentheses. Okay, because we also need to know that coordinate notation. Okay, these should all be parentheses there. So if you want to like kind of fix that, these should not be the little vector things. These should be coordinates. Okay. This is like those rules we saw yesterday, where if we reflect over the x-axis, that takes xy and changes it to be x comma negative y. Okay, that's this kind of thing right here. Okay. But again, this is pretty straightforward. Yes, Ikeva.
Why are things like x plus a and x minus a?
Because the idea is, if we're translating a units to the right, what moving right or left affects what coordinates? Dominic and Ramel, please stop. When you translate a units to the right or left is controlled by the x coordinates. So if you're moving a to the right, you're gonna add a to your x value. Okay.
What is x and y? Like
Those are just a generic point. So like any generic point you have on your shape,
I know. Like,
come x, y, you add a to it to move to the right.
Can you use the example up there? Because like that's confusing.
Well, let's do an example. Actually, let's move on to the example right down here.
I need you to take your attendance.
I just took it, so I think maybe, yeah. Right, thank you. Sorry for my delay. Okay. All right. Okay, so, example, I'm pretty sure I just took it. Let me just check to make sure. Yes, it's showing as being checked. Okay. So let's look here now at example 2, okay, and let's see this in action. So here our pre-image coordinates are -2, 1, -3, -2, and -1, -2. And the vector is in component form 4, 6. So that positive 4 there means we're going to move what direction? Right 4. And the positive 6 means we're going to move up 6. So right 4. And that means up 6. Okay, right? The x-coordinate determines whether we move right or left. The y-coordinate determines whether we move up or down. And so if you look here, they make a little table. Here are the original coordinates, x comma y, that we started with, these ones right here, these 3. And then the image, and look what we do. We take our x-coordinate and add 4, because we're moving right 4. We take our y-coordinate and we add 6, because we're moving up 6. And then there are our translated points.
So how do you know which one to use? Which rule?
Well, we combine them here. It's a matter of just trying to figure out. Since we're trying to move right 4, we add 4 to the x.
Oh,
Since we're trying to move right up 6, we add 6 to the y.
so the rules up above they don't use.
It's more. That's just like, again, it's like those are like the generic kind of rules, but it's just more like just use your numbers to move things.
So if your vector was, let's say, -2 and +3, you would take that first point.
It would be x minus 2, y plus 3. And you just take the first point, subtract 2 from the x-coordinate, add 3 to the y-coordinate. Okay? Which is what we're doing, right, when we move these things. So anyway, if you look here, here's ABC, the original points, the triangle. And you can see they have the vector drawn in here, okay, going right, 1, 2, 3, 4, and up, 1, 2, 3, 4, 5, 6. There it is. Okay, right 4, up 6. And then there's our new shape translated. Again, all these vectors from A to A prime, from C to C prime are the same. Be very careful here. Some students, when they're drawing their vector, their temptation is to draw this. Can you guys see that okay? Their temptation is to draw from here to there. Why is that incorrect? It's not the same point, right? We're going from A to C prime. That is wrong, okay? And you can kind of tell it here too, because look, compare this vector, which is the correct one, to this one. They're obviously not the same vector, right? One's shorter, and they're not parallel to each other either. And that's a problem. That's not right.
Wait, so...
No, I'm just trying to show you. If you want to show the vector here, it's got to go from A to A prime. It's got to go from here up to there. And now you can see they're parallel.
I have a question.
Yes.
So for like... So, like, on that one where it tells you, like, where to move the, like, the translation.
Yes.
And then it says, like, +4, +6. Is that, like,
Yes.
the ones you're supposed to move it by? Like,
Yes.
so you would go
You move the
over
x coordinate +4 and y +6.
Okay.
Exactly. And again, that's all shown here in the vector, right? 4, 6. Or it's also shown in this vector. You go right 4, up 6. So it's all, like, 3 different ways to the same thing. Both 3 different ways that we need to be comfortable with. So let's see this in practice here. So letter B. Okay? Letter B. Let's do this one here real quick. So here are pre-image coordinates already listed, and here's our vector. Okay, there's our vector. So, let me see here. Let me pick, so Julio, this vector, -2. That means what are we going to do to our x-coordinate? So we're going to go left 2, so that means it's going to be x minus, and then a 2 right there. Okay, for our coordinate notation. Exactly right. And then Zaria, this 3 is +3 here. How's it going to affect our y coordinates? We're going to go up or down 3 if we have a +3 there. Up 3, right. So the y plus 3 then is what we'll do. Okay? Now, do you have to make a table when you are asked to translate? No. But since the table's here, let's fill it in because it's there, okay? Let's just make it very explicit. If you have trouble doing these, it's a great idea to make a table like this, okay, to help you organize your work. So, hang on, let me pick somebody. So, Josh, can you see this okay? Okay, so I'm going to take the point 3, 0, and what's the new x-coordinate going to be? Very good, and you did that by doing 3 minus the 2 there, good. And then how about the new y-coordinate? Good, and can you do the next one for me too? 0, and then, yep, +1, and let's go ahead and do the third one since you're on a roll here. 2, 1. Great job.
I already
I
finished.
did that my calculator and I got 5, 3, 4, 1, and 6.
Why would you need
3 minus 2.
No, it would be 3 minus -2.
The minus was, I agree, I hear what you're saying. The minus was already kind of put in there for us. I don't like that they did that. It should be x plus -2 there.
So what's the formula? Because that's, like, what's the formula?
It should be x plus this number,
Okay.
comma, y plus that number. But they already put the minus sign in there, so that makes it a little confusing. So yeah, that's why it's really the way I showed it to you there. Okay. All right. So then let's see here. Let's go ahead and plot the original. I'm going to do that in blue because typically when you see blue, that means the original. So 3, 0. That's A. B is 2, -2. And then C is 4, -2. Okay, so right now, what quadrant is this triangle within of our coordinate axes? You guys remember those quadrants? This is quadrant 4. I remember these are how they number them. 1, 2, 3, and then this one's 4. So if we translate it left 2 and up 3, which quadrant do you think it's going to end up in? If we're going to move this thing left 2, up 3? Probably quadrant 1, yeah. And in fact, let's see. So let's see what happens. We'll put our new points down. So 1, 3. That's A prime, I think. Oh, they didn't label the points here. That's bad. We should label these. This be A prime, B prime, C prime. So there's A prime. B prime is 0, 1. And then C prime is 2, 1. And there it is. Okay, there's our triangle. And you guys are right. Good job. It goes to quadrant 1. Okay. All right. So go ahead. I'd like you guys to try numbers 5 and 6 there. Go ahead and translate those. If you want to make a table, feel free. Okay, if you want to make a table, feel free. But if you don't feel like you need a table, that's okay. Just do it without the table. Oh, I'm sorry. Yes. Did we have a question?
What did you
Just
want
to get finished copying down.
What do you want us to try?
Try 5 and 6 there on the
Okay.
page. Try 5 and 6. Okay, go ahead and do those real quick. We're almost done, by the way, guys. Almost done. Okay, just one more little thing we're going to look at, and then we'll get you guys started on your homework, and you'll have a good amount of time to work on that. Okay. So again, go ahead and try 5 and 6. Okay, Haley and Jaden, if you didn't hear me back there, I know you're copying stuff. We're doing 5 and 6 now.
They shouldn't have to anyway. It probably would be negative 2, 5.
Correct. You got them both?
No, what do you do after
You the original points, then translate in the directions it says translate using that vector. Once you got the original points down, you have to write translate using the
to a
vector.
different shape?
That means you need to recheck your counting then. So check your points. Don't erase the whole thing, just check your
Okay.
points. You probably only made a mistake on one of them. So just recount them. But good catch there, Kyle. That's good eyes.
But it makes, it's just, has to be that first point, I think. -2. Oh, yes, I see what it is.
Good.
I know I made a syllable mistake, okay.
Okay.
So x minus 4 is correct. It should be y plus 1 though, because the y point is 1, so you add 1 to your y point right there.
Question? All right, let me get back there. Let me get back there.
So let's see. So you went. Sorry, left 4 up 1. I'm sorry, I'm sitting there. Yeah, that was good. Yeah, that was good. Yeah. All right, question back here. Yep. You got it, yeah, exactly right. Don't raise the label if I wasn't done that. That's exactly right. That's all you have. I don't think you went up one. Yeah, so all of these be shift up 1 there. Okay, buddy. Looks good. Hands still busted though. Did you punch a fastball?
Oh, Ramel, did you do that the other Ramel, did you do that the other day at the gym? Did you do that yesterday at the gym? What happened? What happened?
For real? Okay. That's good.
No, I remember him doing something when he went up for the ball, right? Didn't you do something when you went up for the ball or something like that?
Well, so yeah, if you get contact and contact for, school and then it helps.
I can't hear.
All right, guys. Real quick here. here we go. Let's take a look. I only did number 5 because I want to show you here, okay? So number 5, I did so thoroughly, okay? I did a little table, right? I started with x, y, I then did the arrow, and then it was x minus 4, y plus 1, right? Because that's what we're doing to our coordinates. I wrote down my original points, then I wrote down the translated points with the, primes. Do you have to do this? No. It didn't say to make a table or anything like that. It just says draw the pre-image and the image of each triangle under that translation. So if you just have this, that's fine. But here's what I want to show you, though. If you're having trouble, okay, this little table is going to be helpful to make sure you get those points accurately, okay? But otherwise, you can just plot your points here, like P, and Q is 2, negative 3, and then R is 4, negative 3. Okay, draw your original. And then like you guys, some of you did, you just started at one of your points, like P, for example, and we're going to go left 4, 1, 2, 3, 4, and up 1, and there's P prime. Okay, and then left 4 from Q, 1, 2, 3, 4, and up 1, there's Q prime. Okay, if you want to be tricky, like I said before, I know that the distance from Q to R is 2 to the right. So from Q prime to R prime, had better be also 2 to the right. So that should be R prime, and sure enough, if I count it, 1, 2, 3, 4, up 1, then there's where R prime should be. So you can also use your shape to help you get the other parts.
Good job, Mr. Wood.
Thanks, Derek. I practice when you guys aren't around. All right, so once more, last thing here, okay, you need to be able also to identify the component. So here it says specify the component form of the vector that maps triangle ABC to triangle A prime, B prime, C prime. So here, it's kind of already shown to us. We just need to name the component form of this vector. So again, what's the direction this vector is going? It's going down, how much there? Well, Matt's not here.
Not going down.
Evan, how much is this vector right here in example A going down? Can you count it there? You might want to use your paper. Yeah, down 4, so I'm going to represent that by a negative 4, and then it's going right how much there, Evan? Okay, so we'll represent it by a positive 5 because it's going to the right. Okay, so there's our vector in component form. It's 5 for the x part, negative 4 for the y part. Okay, that's the vector. Vector V with a little part of an arrow there. Okay, so that's how you name the vector. So let's look real quick here at this one, letter B, and then we'll give you guys your assignment. You can start on that. Okay. So notice here in letter B, it's not drawn for us. We don't have a vector drawn for us here.
I'll take care of it for us.
So we can draw one, okay? So let's just pick a point. Let's say point A. If I'm going to draw a vector that starts at point A, listen up please. It's got to go to point what? A prime. That's right. So there's my vector. It's got to go from A to A prime. So there's the vector. We can call that vector V as well. Okay, so V with a little half an arrow on it. And then we'll just count how it's going. So let's see here. It's going 3 up. And then right 1, 2, 3, 4, 5. Okay. And so then my vector is going to be 3, 5, right?
5, 3.
Yeah, Mr. Whitmire, no. It's got to be 5, 3. Why does it have to be 5, 3? The first number is the x direction. The second number is the y direction. So be careful. We counted it 3, 5, but it's really 5, 3 for the vector form. Okay, so we're just going to write it here. I mean, I guess it's supposed to really go right in there, but whatever. They have us fill out. Oh, sorry, you can't see that. They have us fill out all this other junk here that we don't really need to do. So, okay. So there it is. All right. Any questions on that? Does that feel better than reflections? Yeah. I hope so. All right. So, next page, we'll start your homework. You can go. We're going to do 1, 2, 3, 4, 5, 6, 7. 8, 9, 10. So all the problems on that page. So all the problem on this page 69 here. Okay, we're going to skip 11 because the EK said so. Just kidding, I was going to skip 11 anyway. Look at that, guys. You don't want to do number 11? Oh, it's like a little story right there. Emma and Tony are playing a game. Each draws a try. All right. Yeah, reading, right? Who wants to read in a math class? All right, 12, 13, 14, skip 15, and do number 16.
Alright, sounds good. Get 'em started.
Okay, and that's it. So just that one page, that one sheet. This is it. This, homework. Well, I want you to work on it now because we have time in class. So get started, please. Okay? Some of you guys are so good you'll knock out half of it right now. Or all of it, that's right. So let's get started.